Today we're going to talk about chain other than roller chain. So let's start with silent chain. Now this is a piece of silent chain. And this is silent chain. Here's another piece of silent chain in a larger section. Actually, there's no limit as to how wide silent chain can be made, since it's composed of a series of side plates held together by pins. The term silent chain is somewhat of a misnomer. It's not completely silent, but as compared to roller chain, it is much quieter. Silent chain feeds relatively straight onto a sprocket, and as a consequence, doesn't make much noise. Roller chain must have a roller to match the sprocket, and the pounding which occurs when they make contact creates noise. Silent chain has a straight edge, as you can see, and the contact made is more like two gears meshing. The most common usage for this particular type of chain is in the automobile. There it's called timing chain. Timing chain is used in most automobiles throughout the world. There are special modified types of chain. For example, there is one type of silent chain that actually drives the Toronado automobile, and without it, this automobile would not be possible with the particular type drive that it has. The main wear areas of this chain differ from roller chain. Since it has a straight side, here on the tooth, the wear area is primarily in the pin. Silent chain varies from manufacturer to manufacturer, and the variance is in the method of pinning. First, there was the solid pin type shown here. In this case, a hole is punched in the plates and a solid pin is inserted. Since the pins wear directly on the plate, this type wears rapidly, and as a consequence, most manufacturers today use one of the other styles. Then came the bush pin, which has a solid bushing and pin. In this case, the bushing and the pin being more compatible bearing materials and having more bearing surface. Both make for longer life. Next, the split bushing was designed. Finally, the rocker pin type. On this type, we have a straight side here and a rocker or roller on this side. This type has rolling action at the joint rather than sliding action. So silent chain differs from manufacturer to manufacturer, but the pin is what determines the difference. In years past, chains were not interchangeable from manufacturer to manufacturer. Everyone made their own pitch chain and their own configuration of the tooth of the chain. But today, if the chain you're using is prefixed with the letters SC, it will be interchangeable with the comparable pitch chain from another manufacturer, which is also prefixed with the letters SC. This SC means the chain conforms to ASA standards. You will not, however, be able to use another manufacturer's connecting link or a section of another manufacturer's chain because the pins are usually different. If you make a total chain replacement, it will work on your standard sprocket as long as the SC prefix appears on both chains. One other way various silent chains differ is in the method of guiding. This particular chain is known as a center guide. And this means we have a solid link here, and this style is used with a sprocket which has a groove cut down the center. This way it wraps over, and the center guide holds it on the sprocket to keep it from running off. We can have side guide chain, which has, as you can see, side bars that stick down. The side guides keep the chain from running off. With wide chain, center guide is used more frequently than side guide. With extra wide chains, there may be multiple center guides. In addition to the ones I've shown you, there are various other types of silent chain. Duplex chains, for example. This is where you have a chain that must run on one sprocket, then bend in the opposite direction so that the backside may also drive a sprocket. As shown here, duplex chain will bend back in the opposite direction, and this allows it to run with teeth on one side and teeth on the opposite side. In addition to this, we have what is known as reversible chain. It differs from the duplex chain in that there is a tooth on the opposite side every other pitch. One faces one direction, one faces the opposite direction. Thus, with double pitch sprockets, that is, sprockets with every other tooth missing, we're able to drive from either side of this chain also. Now we get into a completely separate division of chains, and this is engineering chain. One of the first types of engineering chain to be developed is known as detachable link. This particular chain is normally made of cast malleable, and each link is individual and by itself does not have any moving parts. The two slide together through the groove here and make up a unit as shown here. This is relatively old chain which has been used for a number of years. It is primarily for conveyors and elevators in relatively light service at slow speed. It can be fabricated from pressed steel, and to give a similar configuration, this type chain is frequently used in agricultural chain and other similar light-duty applications. This is obviously one of the most economical chains on the market. Now we get into what is known as pintle chain. This particular one is class 400 or relatively light-duty pintle chain. It is obviously heavier than the detachable link chain and is used in elevators, conveyors, and for power transmission as well. By the way, on all of these chains I'm covering, there are all types of attachments. These attachments are used as a method of tying or connecting something to the chain. With these attachments, we can pull various items such as buckets, elevator slats, or conveyor slats. They can also be used in sewage treatment plants. So keep in mind, all the chain I'm showing you have various attachments that are available. Here we see a few of these, although there are many more available. Now the barrel is this section here. It is a casting which is integrally cast with the side plates, and we have a pin that's inserted here to connect the two links. The link is normally malleable iron and the pin is normally steel. Next is the class 700 pintle chain. It has a longer pitch, is a heavier duty chain, and is generally used for more abrasive materials. It is frequently used in sewage and water treatment plants. The barrel is integrally cast with the side plates as in the class 400 pintle chain. The next step along the progression is mill chain. Mill chain is similar to pintle chain but is heavier and, if you'll note, has wearing shoes on the bottom to give more wearing surface and abrasive applications. This makes it good for conveyor service. It's basically the same as pintle chain, the barrel being integrally cast with the side bar. Progressively heavier chain is the class 800 steel bush chain. Now, this particular chain, if you'll notice here, has a bushing put into the hole, and this bushing is replaceable along with the pin. This makes for longer life for the chain because the pin and bushing are the points which normally wear out first. Since these can be replaced, you get extended life out of the chain. These bushings are normally hardened steel or manganese steel. Manganese steel is a special steel with work-hardening properties. Now, this means that although it is not hard to begin with service or working, it will get hard. This hardening only takes place on the outer surface, and just underneath the surface, the material is tough, stringy steel. For this reason, manganese steel makes an ideal shock and abrasion-resistant material. Next, we come to combination chain. This is a particularly heavy-duty chain. It's cast, in this case, similar to roller chain construction, except the barrel has no roller. The barrel links are cast integrally with the side bars. We have a pin link, very similar to the pin link in roller chain. This is used in relatively rough, abrasive conditions, such as handling sand, ashes, coal, and wood refuse. Next is drag chain. As the name implies, these are chains that are used to drag materials, the material being trapped in this area. These come in a number of different configurations. This particular one is termed Type H. The same basic idea is used with a steel bar drag chain. This is just a piece of steel that is bent into this configuration with a pin that goes through at this point to tie it together. This is for relatively lighter duties than the normal cast malleable steel drag chain. We also have welded steel chain. Now, this is a relatively new chain, and its usage is probably increasing faster than any other in the chain field. It's composed entirely of welded components. The barrel has been welded at this point and this point to the steel side bars. The chain can be fabricated from any type steel. However, copper-bearing steels are used to provide increased resistance to corrosion. It is available in unheat-treated, all heat-treated, or with only the pins heat-treated. It has one particular advantage as compared to malleable units, in that the attachment can be welded directly onto the side link. This is frequently done because throughout industry there are so many oddball things which need to be tied to a piece of chain, and the desired attachments are not always available. By the way, this particular chain is gaining wide acceptance in industry. In part, this acceptance stems from the fact that in certain applications, such as corrosive or abrasive conditions, malleable sometimes gives trouble. Therefore, any place where you have a trouble spot with other chain you've normally used through the years, welded steel chain should be considered and will often solve a problem. Now we have a different type of chain called rivetless chain. This is made up of a single loop here and two side bars that are connected together with a pin. By merely flipping this side bar around, we can take them right out of the configuration, which makes it easy to assemble and disassemble. This particular chain is most frequently used in overhead conveyors, and there's probably as much of this type chain used as any other kind because of the quantity used on a single conveyor. It is also especially good for flight conveyors, on applications where the material handle tends to pack in fully enclosed chain joints. This whole unit is normally of drop-forged steel and may be heat-treated or not, depending on the service. It's also available in various alloys for special application. Next, we have steel block chain. There are several styles of steel block chain. This type chain is primarily used in the steel mills for handling very heavy loads at relatively slow speeds. It is available with a number of different attachments to carry, for example, a billet or a roll of coiled steel. The attachments can be inserted in any one of the links. Now we have drawbench chain. Drawbench chain is of an extremely rough chain design using high-grade steels which are carefully heat-treated. This heat treatment is used to give the chain superior strength. The superior strength is needed because a drawbench is where we pull a mandrel through hot metal, and as a consequence, the chain must have tremendous strength. Drawbenches are normally found in steel mills or tube fabricating mills. Bar loop chain is next. Bar loop has a bar that is looped around, as you can see, and this then goes over a pin. This is used in applications where corrosion would form with slurries around a pin if, for example, we had an enclosed pin at this point. Bar loop chain is used in elevator and conveyor services and with non-abrasive or semi-abrasive materials. Now we have pocket sheave chain, or log chain as it's sometimes called. This is similar to the standard link chain that is frequently used as automobile snow tire chains, or in smaller sizes could be used as a dog chain. This particular chain is used in industry along with pocket sheaves, as seen here, to do such things as lifting a bend gate and in certain crane and hoist operations. The chain is normally made from alloy steel and heat treated. When it's to be used with pocket sheaves, it must be precisely sized, or as the industry terms it, calibrated for the particular sheave it's to be used with. Next we have leaf chain. Leaf chain is composed of a series of side plates pinned closely together with no rollers. The most frequent uses for this chain would be like on fork trucks or for slings to lift heavy equipment or in a pipe wrench chain. This particular type chain is relatively strong as compared to standard roller chain. In addition to what I've shown you, there are actually hundreds of special chain of various types. One that comes to mind is a special type of chain designed for a cotton picker. One of the things that held back the design of a successful cotton picker for a number of years was the lack of a specific chain to do the job. Let's consider some criteria for selecting one style chain over another. First and most important, where and how is it going to be used? Will there be severe shock, like driving a hammer mill? Will the application be an extremely dirty one, such as in quarry machinery? Or are there highly abrasive conditions, such as those you would find in a foundry? How fast will it turn? How much strength must it have? How will it be lubricated, if lubricated at all? All these questions must be answered before a selection can be made. One point we should explain when we mention strength: there are several different strengths to which we might be referring. First, there is ultimate strength. This is the point at which the chain will actually pull apart. This would come from breakage of either the pin or the side plate. It is also possible for the bushings and rollers to fail in ultimate strength, but this is unusual. Next, there's yield strength. At this point, the material will stretch, but will then take more load before it breaks. Of course, if the chain is used with a sprocket, once it stretches, it will no longer operate properly. Next is the fatigue strength, or fatigue limit, as it's sometimes called. This is the load at which, under repeated stress, a material will fail. This limit is considerably under the yield strength. The failure is caused by the formation of a hairline crack, which then proceeds across the cross-section of the part to cause a failure. Sprockets for engineering chain are most frequently made from cast iron. The teeth are not usually machined before service. This is possible because they are normally operating against a cast malleable chain and at low speeds. Where wear is severe, they are furnished with chilled rims. Now, this means that when the casting is made, the outer edge, including the teeth, is poured against a surface which cools it rapidly, and this causes it to be very hard. Another common method to make a sprocket for engineering chain is to burn it from steel plate. Hubs are then welded on one or both sides to make the finished sprocket. If high carbon steel is used, then the teeth may be flame hardened if desired.